GEOINT Symposium 2026 in Aurora, Colorado, one thing became impossible to ignore. Maritime domain awareness was everywhere. And then I came across this recent headline from Sat News. U.S. Space Force integrates domain awareness capabilities into Balikatan 2026. And suddenly it became very clear that maritime domain awareness and space situational awareness aren't separate operational conversations. According to that article, the exercise that was done focused on integrating space domain awareness, satellite communications, missile warning systems, GPS resilience, and real-time tracking of maritime and aerial threats across the Indo-Pacific. And the more I looked into this, the more I realized both Earth's oceans and Earth's orbit are starting to face the exact same GEOINT challenge. Too much data, increasing congestion, and the challenge of identifying which signals actually matter. Hello, I'm Dr. Amanda Analytics, and welcome back to Tech AI Space MI, where we explore the intersection of AI, GEOINT, space tech, and emerging operational challenges. Now look at this for a second. This is publicly available AIS ship tracking data from marine traffic. Every marker you're seeing represents a real vessel being tracked in near real time. And this isn't just showing ship locations on a map. You can pull vessel type, movement history, operational status, destination, speed, estimated arrival times, and route forecasting directly from this platform. For example, here we can see a crude oil tanker traveling from Houston toward Great Britain, complete with routing information, navigational status, speed, and estimated arrival time. And once you zoom back out and start looking at entire operational regions, the scale becomes almost overwhelming. Look at the density of activity moving through the Atlantic shipping corridors, the Mediterranean, and major maritime choke points connecting Europe, Africa, and the Middle East. And this is where maritime domain awareness becomes far more than just ship tracking. Now analysts can start looking for anomalous movement, suspicious routing behavior, vessel clustering, congestion patterns, operational bottlenecks, or unexpected changes in activity hidden somewhere inside all of this continuously changing data. And because this information updates pretty consistently and constantly, operators are dealing with enormous volumes of real-time operational data every single day. Now compare that to what's happening in orbit. This visualization for orbiting now gives you a simplified public view into Earth's orbital environment using publicly available orbital tracking data. You can break objects down by low Earth orbit, medium Earth orbit, geostationary orbit, active satellites, inactive satellites, Starlink constellations, orbital decay, and reentry tracking. Even at a high level, you immediately begin to realize how operationally complex orbital traffic management is becoming. But then, look at this. This visualization from Leo Labs shows the growing density of tracked objects, or I should say activity in low Earth orbit. Green objects represent active payloads, while the surrounding objects include debris, rocket bodies, and unidentified objects currently being tracked in orbit. And unlike maritime traffic, many of these objects are moving faster than 17,000 miles per hour. And this is where the scale becomes difficult to even comprehend. According to ESA and their Space Debris Office, there are currently more than 54,000 tracked objects larger than 10 centimeters, over 1.2 million debris objects between 1 and 10 centimeters, and a whopping estimated 140 million debris objects between 1 millimeter and 1 centimeter in size currently in orbit. ESA also estimates there have been more than 660 fragmentation events, collisions, explosions, or anomalous breakups, contributing to the growing debris environment. And even tiny debris fragments can damage satellites or spacecraft at orbital velocities. I should say high orbital velocities. And this is where maritime domain awareness and space situational awareness begin converging into that same GEOINT challenge. Both environments are now dealing with massive amounts of incoming sensor data, increasing congestion, anomaly detection, operational prioritization, and understanding which signals actually matter. And so, as I said at the beginning of the video, the challenge is not in the data. The challenge is interpreting that data fast enough to support operational decision making. And honestly, this is where AI and machine learning are becoming increasingly important. So whether it's ships at sea or satellites in orbit, analysts can't manually process every signal, movement, or anomaly at scale anymore. That's why you're seeing growing interest in AI-based GEOINT workflows, anomaly detection, clustering, predictive analytics, and data fusion across both maritime and space operations. So as you may or may not have seen in my own SSA research, I focused heavily on how machine learning and clustering approaches can help prioritize high-risk or anomalous activity across increasingly large orbital data sets. And what I find fascinating is the two completely different operational environments, Earth's oceans, and Earth's orbit, are now converging around the same core issue: managing complexity in an increasing data-saturated world. And realistically, this challenge is only going to continue growing as more satellites launch into orbit, more vessels operate globally, and more connected systems generate continuous streams of operational data. So if you want to explore some of these visualizations yourself, highly recommend checking out Marine Traffic, Orbiting Now, Leo Labs, and the European Space Agency's Space Debris Office, because they do a great job visualizing the scale and complexity of these growing operational environments. Thanks so much for tuning in. And if you enjoy content around AI, GEOINT, space tech, and emerging operational challenges, make sure to like, subscribe, and I'll see you in the next video. But before you go, I'd love to hear your thoughts on a particular question. As maritime operations and orbital operations become increasingly data saturated, where do you think AI and machine learning will have the biggest impact? Could it be anomaly detection, predictive analytics, operational decision making, or do you think it's something else entirely? Thanks for tuning in. Take care.